Assalamualaikum and a very good day to all. Today we're going to learn on fuzzy numbers. So the topic that will be covered in this chapter is actually definition, properties, and also types of fuzzy numbers. Fuzzy number is actually under the fuzzy set theory. Okay, and fuzzy set theory is actually already been introduced by Lotfi Askazadeh. He was born in 4th February in 1921 in Baku, Azerbaijan. He got his electrical engineering degree from University of Tehran in 1942. He got admission in Massachusetts Institute of Technology MIT for masters in electrical engineering and graduated in 1946. In 1949, he got his PhD in electrical engineering from Columbia University, USA. He was promoted to full professor in 1957 and also has been director of Berkeley Institute of Soft Computing since 1991. The first paper on fuzzy set theory was published in 1965. Lotfi Azadeh passed away on September 6, 2017 at the age of 96 years. This all information taken from Ashfaq 2018. So now, let's go into the definition of fuzzy numbers. So fuzzy numbers are a type of a set that represents value within imprecision and uncertainty. They have become an essential tools in various fields like finance, engineering, and healthcare, and not to forget decision-making problem. Based on Chen and Chen, a generalized fuzzy numbers can be denoted as A, where the item of it is actually A, B, C, D, and also W, is described as any fuzzy subset of a real number with membership function FA, which has the following properties. The first one, FA is continuous mapping from any real number to the closed interval from 0 until W. So the height attained from 0 until W. FA is equal to 0 for all values of x from negative infinity, from A until negative infinity. The value here is actually 0. And also the last one we represent x is equal to 0 for all the value of x from D until positive infinity. And FA is equal to 0, as this one, represent this one. FA is strictly increasing on AB, and FAW for all x in between B until C. So the height here, our membership function is actually W, the height. And it is strictly decreasing from C until D at this point, where 0 until W is between 0 and 1, and A, B, C, and D are real numbers. When W is achieved the height of 1, we call it the fuzzy number is normal and is denoted by A, B, C, and also D. Now, what are the properties of fuzzy numbers? So many quantifiable phenomena could not be characterized in terms of exact numbers or precise values. The expression about 3 o'clock, approximately 7, or close to 8 are somewhat vague in nature. In the fuzzy set close to 7, for example, the center value, which is the number 7, fully belongs to the fuzzy set with membership degree of 1. Numbers that are on either side of 7 also belongs to the set, but to the lesser degree. The concept of fuzzy numbers are used to represent this kind of fuzzy set. It represent the vagueness, the membership of the function. All fuzzy numbers are fuzzy set, but not all fuzzy set are fuzzy numbers. So now, the fuzzy set A in real number is a fuzzy number if it satisfies the following condition. A is normal, attain the height of 1. A is convex here. A has a bounded support. Okay, here's the bounded support. And the alpha cuts of A are in a closed interval of R. So the alpha cut is in the bounded in a closed interval. So these are the properties. Now, let's look at the type of fuzzy numbers. So fuzzy numbers can be represented in several forms such as triangular, trapezoidal, Gaussian, and also S-curve. In many cases, method of ranking fuzzy numbers only focus on ranking linear form of fuzzy numbers such as trapezoidal and also triangular fuzzy numbers. Fuzzy numbers A is linear if the membership function of the fuzzy number Fa is the first degree of polynomial of one variable. So example of linear form of fuzzy numbers are as follows. So the first type of linear is we call it triangular fuzzy numbers. So this is the membership function. where in between A and also B, this is the function. And in between B until C, these are the function, where C minus X over C minus 5 as minus B. And the rest of it elsewhere is 0. So this is triangular fuzzy numbers. The second type of linear fuzzy numbers, we call it trapezoidal fuzzy numbers. So trapezoidal fuzzy numbers can be presented by the membership function here. Okay, in between A until B, so this is the function. In between C until D, this is the membership function. Okay, on top of this, in between B until C, the membership function is 1. Okay, elsewhere is 0. So this is trapezoidal fuzzy numbers. Now, the second type of fuzzy numbers, we call it nonlinear. In other words, the membership function of FA of the fuzzy number is not a first degree of polynomial. Among types of fuzzy numbers that are described by nonlinear membership function are Gaussian and also S-curve. Now, let's look at the types of Gaussian fuzzy numbers. So, Gaussian fuzzy numbers can be represented by the membership function. Figure 5 shows the illustration of Gaussian fuzzy numbers. So this is the representation of nonlinear membership function of Gaussian fuzzy numbers. And the second types of nonlinear membership of fuzzy numbers, we call it S-curve. And it is actually can be represented by this formula, this membership function. And this is the illustration of it. Okay. So basically, fuzzy numbers can be divided into two parts. The first one is linear and nonlinear. Usually, in application in decision making, researcher decision maker always use linear depending on the suitability of the application. So these are the references. Thank you.